Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, the measures of the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Okay, so we have some quadrilateral. Some, I don't know, four-sided shape. We don't know what it looks like, but we know that one of the angles is x, one of them is 3x, one of them is 5x, and one of them is 7x. So this is not an accurate drawing of this at all, right? The x angle should probably be smaller. The 7x should be 7 times as big as the x angle, but not really important. I don't need to draw it to scale. The question didn't ask me to draw a perfect quadrilateral with these measurements. It just said to find the measures of all of the interior angles. So, how many degrees are there inside of a quadrilateral? Remember, our corollary to the Polygon interior angles theorem says that there are 360 degrees in a quadrilateral. The measures of the interior angles of a quadrilateral is 360 degrees. So that means that if I take x plus 3x plus 5x plus 7x, I will get 360 degrees. Now, let me combine my like terms. So everything that has an x in it, I can combine. So I have 1x plus 3x plus 5 plus 7. So 1 plus 3 plus 5 plus 7 is 16. So I have 16 x's. I just added the numbers in front of the x's, and that gave me 16. 16x equals 360 degrees. So I need to divide by 16 on both sides. 360 divided by 16 is 22.5 degrees. 22.5 degrees. So now I need to figure out the measure of all the interior angles. So, all the interior angles. So now that I have x, I need to plug this in to the x in each of the angles so I can figure out what each of the angles is. So I know that this angle, it's 22.5 degrees because it's just x, and x is 22.5 degrees. But 7x, to find the 7x, I'm going to need to do 7 times 22.5 degrees. So 7 times 22.5 degrees is 157.5 degrees. For the 5x, I'm going to multiply 22.5 times 5. 22.5 times 5 is 112.5. So this angle is 112.5 degrees. And the 3x, that's 3 times 22.5 is 67.5 degrees. So there you go. Once we plugged in x, we found what the measures of the interior angles were. Now we can check our answer by doing 22.5 plus 157.5 plus 112.5 plus 67.5, and we need to get 360 when we do that. And we do. We do get 360 when we do that. So, awesome. Awesome. We are finished. And let's move on to what we have for today. Now, today is the last day of section 7.1. We're going to finish talking about angles of polygons by bringing exterior angles into the mix. So our learning target for today is that you remember what exterior angles of polygons are, and our success criteria is that you can find interior and exterior angle measures of polygons. So we're going to bring it all together today and finish off our conversation, our exploration of angles of polygons. To remind you what a polygon is, it is a closed figure in a plane that is made up of 3 or more line segments that intersect only at their endpoints, just like these pictured here. And equilateral, equiangular, and regular polygons, we're going to talk specifically, our last example for today is going to talk specifically about regular polygons. So remember that equilateral means all sides are congruent, equiangular means all interior angles are congruent, and regular means both equilateral and equiangular. So make sure that these are in your notes. They're probably in your notes from a couple days ago. If they're not, write them down now. And remember these things for our examples today. Before we jump into the examples today, we need to talk more in depth about these exterior angles. The last 2 videos, you have seen this slide, but we've only really mentioned interior angles. We mentioned exterior angles, but we only talked about interior angles. So today our focus is on the exterior angles. Of course, interior angles are the angles inside of a polygon, but exterior angles are angles that form linear pairs with the interior angles. So some people, originally when you say exterior angles, they think, oh, this whole thing, like that's bigger than 180 degrees. That's like over 300 degrees in some case. But that's not what we're talking about. We're not talking about that type of exterior angle. What we're doing is we're extending the sides of each triangle, and you can think about it this way too. But in this example, they extended one side, so they didn't extend both sides. They picked just one, and we're looking at one of the angles that make up a linear pair with the interior angle. So it might be easier if I explain it this way. If we look at this angle B, this one right here, if I draw it over on this diagram, we see that it's this angle right here. Now, notice that that is a vertical angle with the angle on this side. So it doesn't matter. It doesn't matter if I use the extension of side BC or if I use the extension of side AB. It doesn't matter because both of these angles are going to be congruent. Remember, all vertical angles are congruent. What we don't want to do is use both of these angles. When we talk about exterior angles, we only want to use one. So I can use the one on the right, or I can use the one on the left. But I don't want to use both. So, yeah, in this picture, they decided to use all of the ones. They decided to extend just one side of segment BC, and that's okay. As long as we're not, counting both of the exterior angles. We only want to count one exterior angle for each vertex. So, we're taking each vertex, A, B, and C, in this case because it's a triangle. We're taking each vertex and extending one of the sides and taking the angle that forms a linear pair with the interior angle. So remember, a linear pair means that we're adding up to 180 degrees. They are supplementary. They're on a line. Linear pair means together on a line. So we can see that this interior angle A and this exterior angle A are on a line and form 180 degrees together. So that's what makes it an exterior angle. A lot of people think of this when we say exterior angles, but remember that is not what we are talking about. We are talking about angles that form linear pairs with the interior angles. Okay? And you can see that maybe a little more clearly in this example, that these angles right here add up to form a linear pair. Okay, so that's exterior angles. I'm going to remind you really quickly of our polygon interior angles theorem. Number of sides minus 2 gives you the number of triangles in a shape, and the total number of degrees is equal to the number of triangles times 180, because there's 180 degrees in every triangle. We are going to use this in the last example, so keep it in your mind. I know we've seen it the last 2 videos. Keep it in your mind, because now we're going to go back to the exterior angles, which is the focus, the main focus of today's video. So, unlike the sum of the interior angle measures of a convex polygon, the sum of the exterior angles does not depend on the number of sides. So the interior angles, we had n minus 2 times 180, and depending upon what n was, this answer was different. If n was 3, well, we just had 180. If n was 4, we had 360. You know, if n was a bigger number, we had a bigger answer. When it comes to exterior angles, the sum of the exterior angle measures does not depend on n. Doesn't depend on the number of sides. The diagrams below, so these diagrams is what they're talking about, suggest that the sum of the measures of the exterior angles, 1 at each vertex, not both of them, just 1 at each vertex, like they numbered here. The sum of the measures of the exterior angles of a pentagon is 360 degrees. In general, this sum is 360 degrees for any convex polygon. So this is not a rigorous proof by any means, but this is a way to kind of intuitively understand why the exterior angles of polygons will always be 360 degrees. And we're going to see that theorem on the next slide. But so if you take each of these colored angles, the 1, 2, 3, 4, 5, and you cut them out and you put them together, notice that they form a circle. How many degrees are there in a circle? 360 degrees in a circle. So, this diagram works for any polygon. In this example, they used a pentagon, but it actually works for any n-sided shape. So, this leads us to our next theorem, which is the polygon exterior angles theorem, which says the sum of the measures of the exterior angles of a convex polygon, 1 at each vertex, not both like we talked about, don't extend both sides and use both of these angles, 1 at each vertex is 360 degrees. So no matter what polygon it is, no matter if it's an n, if it's a 5-gon, a 7-gon, a 13-gon, doesn't matter. If you add up all of the angles, you will get 360 degrees. For the exterior angles, remember our polygon interior angles theorem is very different. This is for exterior angles. So, put this in your notes. Make sure that exterior is emphasized when you put it in your notes. And let's do an example with this theorem. Find the value of x in the diagram, finding an unknown exterior angle measure. So, we want to find the value of x in this diagram. Now, do I need to count the number of sides that this has? No, I don't. I could, for fun, if I wanted to, but because we're talking about exterior angle measures, I know that they're all going to add up to be 360 degrees. Because that's what the exterior angle theorem says, is that all of the angles add up to 360 degrees, no matter what polygon I have. no matter how many sides there are. So, we know that 2x plus x plus 67 plus 89 should be equal to 360. Let's combine our like terms. 2x plus x is 3x, and 67 plus 89 is 156, and that is equal to 360. Subtract 156 from both sides, and I get that 3x is equal to 204. Divide by 3 on both sides, and we get that x is equal to 68. Now, am I done? Actually, the problem said to find the value of x. So yes, I am done. If it said find the measure of each exterior angle, then I would plug this back in, figure out what 2 times 68 is, and this is 68 degrees. But it just asked me to find the value of x. So, we're done. That's it. Let's check and make sure that we were correct. Polygon exterior angles theorem equals 360. X is equal to 68. The value of x is equal to 68 degrees. Ta-da! Okay. Now, our next example has to do with interior and exterior angles. So now you know why we reviewed the interior angles theorem, is because we're talking about both interior and exterior angles. So, the trampoline shown is shaped like a regular dodecagon. Now, let me count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides to this shape. Now, these tick marks that I've drawn are congruency tick marks. Because it is a regular dodecagon, because it is a regular polygon, all the sides are the same, and all of the angles are the same. It is equilateral and equiangular. So all my sides are the same, all my angles are the same. Now, let's look at part A first. Part A says to find the measure of each interior angle. Well, how many degrees are there even in this thing? How can I start talking about a specific angle if I don't know all of them? So, I take n minus 2 times 180, times 180. I know that n is 12. So we have 10 times 180. Oh, which I don't even need a calculator. I can just add a 0 onto the end of 180 to get 1800. So there are 1800 degrees inside of this shape. Now, how am I supposed to find the measure of each one of these angles? Well, wait a minute. If this shape is irregular, it means that all the angles are the same. So we can think of all of these angles as being x degrees. Because they're all the exact same. That's what it means to be regular, is that all of these angles have the exact same measure. Now, how many of these angles are there? We could count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh yeah, 12 sides. There's going to be 12 angles. So, what we have here is we have 12 of the same angle measure, and all of them together need to be equal to 1800. So all we need to do is we need to take the sum of the measures of the interior angles and divide it by the number of sides that we have, or the number of angles we have, which is 12. And what do I get? 1800 divided by 12 is 150. So each of these interior angles is 150 degrees. And a better way we can see that is how I wrote it before. 12x equals 1800, and x equals 150. So each of those little x's in this shape is 150 degrees. Awesome. So the fact that this was a regular dodecagon was the key to this problem. If it was not regular, well then these can't all be x's. Then I would need to have, x plus 2, or, they wouldn't all be the same. They wouldn't all be x. They'd be different. And then, who knows what to do? Not me. Not for this video. Okay. So now, we're going to move on to part B. We're going to look at the measure of each exterior angle. Well, wait a minute. If we have one, right, the exterior polygon, or the polygon exterior angles theorem, said that when we talk about the sum of the measures of exterior angles, we're talking about one at each vertex. Now, how many vertices do I have in this shape? 12. I have 12 vertices, I have 12 sides, so I have 12 exterior angles that are all going to be the same. They're all going to be the same because exterior angles are linear pairs with the interior angles, and all of the interior angles are the same. So all the exterior angles are going to be the same too. And I know that all 12 of these together need to give me 360 degrees. The exterior angles, no matter what, add up to 360 degrees. So, if I divide 360 by 12, I get 30. So the exterior angles are 30 degrees. Now maybe we should have used y here instead of x, so that it's less confusing. We'll use y for exterior angles and x for interior angles. So the interior angles measure 150 degrees, and each exterior angle measures 30 degrees. Now we can check. These interior and exterior angles must be linear pairs. They must add up to 180 degrees. So is 30 plus 150 equal to 180? Yes. Yes, it is. So that's a way that we can check. Another way that we can check is by scrolling down and seeing. Okay, sum of the measures of the interior angles is 1800. Divide 1800 by 12 to get 150. Booyah. And sum of the measures of the exterior angles is 360. Divide 360 by 12 to get 30 degrees. Aha! Yes! That's what we did. And we were correct. Wonderful. Okay. That is all I have for you today. So, it's time to rate yourself on a scale of 1 to 3. How do you feel about our learning target and our success criteria? Do you understand what exterior angles are, how they're made, how they're related to the interior angles? And do you know how to find the measures of exterior angles of any polygon and of any regular polygon? And do you know how to find the interior angles for any regular polygon? So, whatever you are, if you're confused or if you totally get it, be sure to take the appropriate action, whether that's asking questions, trying the homework, or helping your family members, your classmates, your friends. All right, here are some practice problems that you can do to practice the skills you have learned in this video. The first 4 are like example 5, the second 4 are like example 6. And as always, let's end our video with a launch. So today's launch comes from John Dewey, and he says, "Education is not preparation for life." education is life itself. I thought this was very interesting. I really like this quote because when I was in high school, I thought that education should be preparation for life. Education, like school, should make me ready to enter the real world and be a successful human being in the real world. Now, I'm not saying that I don't still think that. Education system could use a redo or, you know, a makeover of sorts. That's a different conversation. But whether or not education is preparation for life, right now, not really doing that. Education is life itself. This is the part of the quote that I like. We can talk about the first part of the quote. We can argue about the first part of the quote. The second part, education is life itself. Now you might think, heck no, school is not life itself. Like school is the worst part of life. You might think that. But think about this. All the things that you enjoy, video games, recording music, playing sports, whatever it is that you enjoy, that has required some level of education. To get good at Rocket League, I need to learn, oh, I can air roll. Oh, if I hit the ball with the front of my car, it makes the ball go further, whatever. Same thing with sports. Oh, if I keep my hands cupped when I swim, I can go faster, or, you know, whatever. Anything that you have wanted to get good at, you have had to learn in order to be able to do that. You had to learn how to walk. You had to learn how to strum a guitar. You had to learn whatever it is that you enjoy doing. And to get better and to, you know, do new things, you are going to need to learn how to do it. If you want to learn how to be a rock climber or how to, you know, rock climb really well, you're going to have to learn how to diet and exercise and get, you know, the right muscles, the right finger strength, all that jazz. If you want to be a successful recording artist, you're going to have to learn how the chords work together, how harmonies work, you know, whatever. So all of life requires education. Typically when we think education, we think of school. Education is not tied to school. You can learn outside of school. You can learn anywhere. So learning is life itself, because anything that you do requires learning. So what is it that you want to learn how to do, and how are you going to do that? So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.